Section 1. The first death, when the stars begin to fade. Look up at the sky tonight. Every pinpoint of light you see, and countless more, too faint for your eyes, is a sun, a self-contained fusion engine turning hydrogen into light. For billions of years, these stars have been the heartbeat of the cosmos. They forged the elements that built planets, oceans, and life itself. But even the stars must one day rest. In the distant future, long after our brief age of humanity has passed, the universe will enter its first great transition, the slow, elegant fading of stellar fire. The end of the stellar era begins. At first, nothing will seem unusual. Galaxies will still glitter like islands of light adrift in darkness. But within those galaxies, the seeds of stillness will already be taking root. Stars are born from nebulae, vast clouds of gas and dust, cradles where gravity gathers hydrogen atoms until they ignite in fusion. For new stars to be born, these nebulae must be replenished by older stars through supernova explosions or gentle shedding of gas. Yet as time flows forward, this cycle begins to fail. Each generation of stars consumes more hydrogen than it returns. Eventually, the galactic nurseries will run dry, and the brilliant cosmic production of light will halt. Astronomers call this approaching epoch the degenerate era, the time when stars no longer form, and the ones that remain begin to die out. The death of the giants. The first to go will be the massive stars, those colossal beacons that live fast and die young. They burn through their fuel in only a few million years, a mere heartbeat in cosmic time. When their hydrogen runs out, they collapse inward, their cores fusing heavier elements, helium, carbon, oxygen, silicon, until iron forms, the element that ends the chain. No energy can be extracted from fusing iron. The core implodes, and the star detonates in a supernova, a momentary flash brighter than an entire galaxy. These explosions seed the cosmos with gold, silver, calcium, and carbon, the ingredients of future worlds and living beings. But in the far future, when no new gas remains, each explosion will be a final exhale, not a promise of new life. The sky will grow quieter, the gentle deaths of small suns. After the giants fade, the smaller, steadier suns, like our own, will continue burning for billions of years longer. They are the slow candles of the cosmos, turning hydrogen into helium at a measured, deliberate pace. When their fuel thins, these stars expand into red giants, their outer layers swelling to enormous size. Our own sun, 5 billion years from now, will engulf Mercury and Venus and paint Earth's skies with hues of red and gold. Then, in a graceful shedding of light, the sun will cast away its outer layers into space, a shimmering shell called a planetary nebula. At the center, what remains will be a white dwarf, a stellar ember, no larger than Earth, glowing softly with the heat of its former life. In time, even that glow will fade. After trillions of years, the white dwarfs will cool into black dwarfs, stars that no longer shine, their warmth surrendered to the expanding night. The red dwarfs, the last to shine. But not all stars die so soon. The smallest of all, the humble red dwarfs, will linger far longer. They burn their fuel with exquisite efficiency, their interiors fully convective, mixing hydrogen so perfectly that they waste almost nothing. Some red dwarfs will live for up to 10 trillion years, outlasting the Milky Way as we know it. They will become the final lights of the universe, glimmering faintly in an ever-growing darkness. To any distant observer in that time, perhaps a machine drifting between galaxies, the night sky will appear almost empty, punctuated by the rare soft pulse of a solitary star. When the last of these red dwarfs finally fades, the universe will experience its first true night, a darkness deeper than any we can imagine. Galaxies in twilight. As the stars die, galaxies themselves will begin to dim. Collisions will merge them into great elliptical remnants, massive structures of old stars and black holes, quiet and red. Over tens of trillions of years, gravitational interactions will fling stars into intergalactic space. The Milky Way and its neighbors will coalesce into one vast system, a single glowing island adrift in emptiness. Then even that will fade. The universe will continue expanding, stretching the distances between these lonely galaxies until their light can no longer reach one another. Each galaxy will drift into isolation, an island in an ever-darkening sea. The silence of light. When the last visible star flickers out, the universe will not end in violence. It will enter a state of gentle quiet. The night will not be black exactly, but filled with faint relics of what once was. The ghost glow of dying white dwarfs, the whispers of cosmic microwave background radiation, the soft hum of particles still moving through space. It will be the first true silence since time began. A pause not of absence but of rest. The poetry of fading. There is something profoundly peaceful about this stage of the universe. The fading of the stars is not a tragedy. It is a completion. Everything that was bright, hot, and alive will have given itself to the future. Hydrogen to helium, helium to carbon, light to space, order to memory. Even as the fires go out, their legacy endures in the atoms scattered across the dark. Every molecule that ever formed life or planet owes its existence to the light of dying stars. So when we speak of the first death of the cosmos, we are not mourning, we are witnessing fulfillment. The stars were always destined to give everything they had so that the universe could become rich, complex, and alive, even if only for a moment. In the next section, we will drift farther into time, into the era of black holes and stellar remnants, where gravity reigns supreme and light itself begins to bend and vanish. Section 2. The Reign of Darkness, when black holes rule the cosmos. The stars have gone out. The great furnaces that once painted the heavens with fire are now silent, their remnants scattered through endless space like ancient embers. The universe has entered its long night, an age where light is rare, and gravity becomes the master of all things. This is the black hole era, a cosmic kingdom of invisible monarchs, where matter bends, folds, and disappears into silence. the last architects of the universe. When the last star burns out, the universe doesn't fall into stillness right away. Its stage remains populated by the relics of stellar death, white dwarfs, neutron stars, and above all, black holes. Black holes are not truly objects in the traditional sense. They are regions of space-time where gravity becomes so absolute that nothing, not even light, can escape. Once thought to be cosmic rarities, black holes become the most dominant structures in this new age. They are formed from the collapsed cores of massive stars, and as the eons unfold, they begin to consume everything left drifting through the void. Stars that wander too close vanish within their event horizons, their light stretched and dimmed until it fades completely. Even the faint dust of ancient galaxies is drawn inward over unimaginable timescales. Bit by bit, the universe's mass collects in these dark, silent wells, the final architects of matter's fate. Galaxies of shadows. At first, galaxies still exist, vast, ghostly structures containing trillions of dead suns. Within their hearts lurk supermassive black holes, millions or billions of times the mass of the sun, remnants of a time when quasars blazed like celestial lighthouses. Now, though, the glow is gone. Only the faint hum of gravitational interactions remains. The slow waltz of dark objects circling darker ones. In this epoch, collisions between black holes are rare, but when they do occur, they send ripples through space-time, gravitational waves, echoes that stretch across the cosmos, faint signatures of invisible motion. Each wave is a whisper from the heart of nothingness, the universe remembering its own weight. Over trillions of years, galaxies will lose cohesion. Gravity will no longer be able to hold them together as the fabric of space itself continues to expand. Eventually, the black holes will be all that's left, adrift in solitude, each ruling over a region of emptiness like a silent emperor. The dance of the dead. For a time, though time here has lost meaning, black holes continue their slow feast. They consume what remains, stray planets, frozen debris, and even the occasional brown dwarf, a failed star still faintly glowing. But their appetite cannot last forever. Once everything near them is devoured, they have nothing left to consume. A black hole in perfect isolation seems eternal, but the universe is never truly still. Even black holes, those most patient of cosmic beings, are slowly dying. The whisper of Hawking radiation. In 1974, Stephen Hawking made one of the most profound discoveries in cosmology. Black holes are not entirely black. Through quantum effects near the event horizon, they can slowly emit radiation, a faint thermal glow now known as Hawking radiation. It's a paradoxical process, born from the dance between quantum mechanics and gravity. Empty space is not truly empty. It flickers with virtual particles that appear and vanish in pairs. If such a pair appears near the event horizon of a black hole, one particle can fall in while the other escapes. To a distant observer, it looks as though the black hole has radiated a particle and lost a tiny bit of mass. Over unimaginable timescales, this process continues. Large black holes radiate extremely slowly, but smaller ones do so more quickly. As they shrink, they radiate faster still, until at last they vanish in a final burst of light. For the largest black holes, this will take around 10 to the 100 years, a number so vast it outstrips any sense of human comprehension. The reign of darkness is long, but even it cannot last forever. The fading of gravity's canes. Imagine this far future, a time when each black hole, once so dominant, has begun to flicker with its own evaporation, a faint hiss of photons escaping into a universe grown unimaginably vast and cold. One by one, they vanish. Supermassive black holes will be the last to go, radiating their final whispers into space long after every atom of matter has decayed. Their endings are not violent, but quiet, radiant, a soft sigh of the cosmos letting go of its last grip on itself. When the final black hole fades, the universe will reach a state of almost perfect entropy, an even spread of energy, no gradients, no motion, no light. It will be the heat death of the cosmos, not an explosion, but a stillness. The still beauty of the end. It is tempting to think of this as a sad fate, a universe dimming into silence, its last fires extinguished. Yet there is a quiet majesty in it. The black hole era is not destruction, it is completion. Every particle, every photon, has lived out its destiny, danced its dance, and returned to the infinite equilibrium of nature. In the silence that follows, the universe will at last be at rest. No gravity tugging, no fusion burning, no chaos stirring, only balance, the eternal calm after the longest journey imaginable. A universe of memory, and yet, even in that silence, something of the universe's story remains. The faint radiation left behind by black holes, the background hum of spent energy, will still carry within it the memory of all that came before. Every light, every life, every dream will echo faintly in that final field of cold photons, diffused and untraceable, but not lost. The universe forgets nothing. It simply becomes quieter with time. This is the reign of darkness, a kingdom where light is a memory, and gravity's rulers are fading away. It is not an age of despair, but an age of completion, the closing act in the long play of cosmic creation. And beyond it, beyond even the death of black holes, there may still lie something more. A rebirth, a renewal, or the infinite sleep of space itself. Section 3. The Era of Decay. When matter forgets itself. The black holes are gone now. Their reign, which lasted longer than all the ages before combined, has ended in silence. Their last whispers of radiation have faded into the thinness of space. And what remains of the cosmos is nearly featureless. A vast, cold sea of drifting particles, faint photons, and ghostly echoes of energy. But even now, in this fragile and ancient expanse, there are still traces of what once was. Atoms, protons, neutrons, the smallest building blocks of everything. For a time, these tiny survivors persist, wandering through the emptiness. They are the final relics of structure, the last witnesses to all that the universe has created. Yet even they will not endure forever, for in the deep future, matter itself begins to die. The last islands of structure. Imagine a universe without galaxies, without stars, without even dust or gas clouds. It is not entirely empty. Not yet, but what remains is scattered and faint. Tiny remnants still drift in the void. Cold iron spheres, dark fragments of ancient white dwarfs, or frozen planets wandering without a sun. But these too are subject to decay. Over unimaginable eons, far beyond the lifespan of any black hole, the very atoms that compose these objects begin to come undone. This is the era of decay, when the laws of physics themselves allow the universe to dissolve into its most fundamental form, the slow death of the proton. At the heart of every atom lies the proton, a particle so stable for so long that it has outlived stars, galaxies, and even time as we know it. For decades, physicists debated whether protons could truly decay. Experiments on Earth have not yet seen this happen, but many grand unified theories suggest that even protons will not last forever. If these theories are correct, each proton has a half-life of roughly 10 to the 34 to 10 to the 36 years, a number so large it defies the imagination. When a proton decays, it does not explode, it simply transforms. Its quarks rearrange, producing lighter particles like positrons and neutrinos, and releasing a faint whisper of energy, a sigh from the very heart of matter. This process is unimaginably slow, but relentless. Over time, it means that every atom in existence will eventually dissolve. The solid iron cores of ancient planets will turn to mist. Molecules will lose their cohesion, and even the densest matter will fade into a diffuse glow of radiation. Matter, as we know it, will forget itself. The universe becomes transparent. As proton decay progresses, the universe begins to change in character. Where once there were particles that could absorb or scatter light, now there are only waves of radiation, passing through endless emptiness. The cosmos becomes transparent, clearer than glass, empty of obstacles. Light no longer travels from one object to another, because there are no objects left, only the quiet shimmer of photons, their wavelengths stretched by the expansion of space until they are too long to carry energy in any meaningful way. It is the stillness of entropy, the soft equality of everything. The fate of neutrons and neutrinos, even before the protons decay, free neutrons, those unbound by atomic nuclei, are already unstable. They last only about 15 minutes under normal conditions. In this far future, most neutrons have long since vanished, leaving behind a universe ruled by radiation and sparse electrons. Neutrinos, however, those ghostly, nearly massless particles, remain. They stream through the universe unhindered, barely interacting with anything at all. Even when the rest of matter fades, neutrinos continue to exist. Silent travelers through the cold abyss. They, along with low-energy photons, become the last true inhabitants of the cosmos, a population of near-nothingness. Decay as a form of balance. Though it may sound tragic, the idea that even atoms, those most enduring symbols of permanence, will one day cease to be, there is also peace in it. Decay is not destruction, it is balance. The universe began in overwhelming order, a hot, dense burst of energy, teeming with potential. And ever since, it has been spreading that energy outward, equalizing, cooling, finding its way toward stillness. The era of decay is not a fall from grace. It is a return to equilibrium, the natural rhythm of existence completing its final cycle. Each proton's death is a soft exhale of the cosmos, a release of stored energy back into the field from which it once came. The same process that once gave rise to stars and life now guides the universe toward perfect symmetry. The loneliness of time. By now, the scale of time has become meaningless. Trillions of years pass without change. No galaxies drift by. No stars flare or die. No orbits exist. Space itself has stretched so far that the few remaining photons rarely cross paths. If there are still observers, machines, consciousnesses, or remnants of civilizations, they would experience existence as a quiet hum of background radiation, a gentle, fading glow that carries the entire memory of creation. But even observation loses its meaning. There are no contrasts, no differences, no energy to fuel thought. The universe forgets how to change, and thus forgets how to become. The shape of nothing. By the end of the era of decay, the cosmos will be a thin field of low-energy photons, electrons, positrons, and neutrinos, drifting through an ever-expanding space-time. The density of matter will be so low that within a volume the size of the Milky Way, there might be only a few dozen particles left. Yet paradoxically, this emptiness is not barren. It is the fullest expression of balance, the universe having spread its energy perfectly evenly. The cosmos began as an explosion of difference, hot and cold, light and dark, matter and energy, and ends as unity. The beauty of forgetting. If you could stand, metaphorically, within this far future universe, you would see nothing. You would feel nothing. You would hear nothing. And yet, you would be inside the purest calm imaginable. The stillness that every storm, every fusion reaction, every heartbeat of the universe was ultimately leading toward. The universe has not died, it has simply completed its thought. It has exhaled, and in that exhale, it has forgotten itself, not in sorrow, but in peace. Section 4. The death of space and time, when expansion outruns existence. The universe is quiet now. No stars, no planets, no forms of matter remain. Only a thin, invisible haze of radiation and a few stray particles wandering through the endless dark. Yet even in this stillness, the universe continues to grow. The fabric of space itself, the invisible grid that holds everything, is stretching faster and faster, driven by a mysterious force known as dark energy. And though there is almost nothing left to move within it, space continues to expand. It is not stretching into anything. It is simply creating more of itself. The stage is widening, even as the actors have long since vanished. The accelerating void. In the early 21st century, astronomers discovered that the expansion of the universe is not slowing down, as once believed, but accelerating. Something unseen, something that makes up nearly 70% of all cosmic energy, is pushing galaxies apart faster and faster with time. We call it dark energy, but the name hides more than it reveals. We do not know what it is, only that it exerts a pressure on space-time itself, causing the universe to expand exponentially. In our current epoch, this acceleration is gentle. Galaxies beyond our local group are already receding too quickly for their light to ever reach us, vanishing over the cosmic event horizon, never to be seen again. But in the far future, when even the faintest photons have faded, this expansion will continue, and the consequences will be profound. The horizon of nothingness. To imagine the future of the cosmos, we must think not in billions, but in trillions upon trillions of years. As dark energy drives the universe apart, the observable horizon, the region of space from which light can still reach any given point, shrinks. Eventually, even nearby regions of space will be moving away faster than light itself. This does not violate physics. It is space-time itself that is stretching. The galaxies, particles, and photons are not moving through space. They are being carried with it. In this way, isolation becomes absolute. Every surviving particle becomes trapped in its own tiny bubble of space-time, unable to communicate with any other. Each is alone forever. The end of connection. In the distant past, the universe was a network. Everything connected to everything else by light, gravity, and motion. Now, all connection dissolves. Photons, the messengers of light, are redshifted by expansion until their wavelengths become longer than the visible universe itself. Their energy becomes infinitesimal. They no longer exist in any measurable sense. Even gravity, that most stubborn of forces, loses its reach. For gravity depends on mass, and mass depends on matter, which by now has decayed into radiation. There are no more orbits, no more interactions, no more relationships of any kind. What remains is not a universe in the human sense, not a space filled with stars and galaxies, but simply space, stretching without end, silent and unobserved. The fate of the metric, in the language of physics, the shape and behavior of the universe, are described by a mathematical structure known as the metric, a measure of how distances and times relate. In the earliest moments after the Big Bang, this metric changed violently, expanding faster than light, creating all that would ever exist. Now, in the twilight of time, the metric changes again, but this time it expands into stillness. As dark energy continues to dominate, space-time becomes increasingly empty, flat, and inert. At a certain point, the fabric of reality reaches its limit. Distances stretch so far, and time dilates so much that causality, the link between events, breaks down. No cause can have an effect. No moment can lead to the next. The universe becomes a collection of frozen, disconnected instants, like a film reel whose frames have stopped flowing. Time itself loses meaning. The dissolution of time. We often think of time as a river, flowing steadily forward, carrying us from one event to another. It exists because things change, because motion and cause and consequence exist. In this future, when there is no energy gradient, no particle movement, no potential for change, the river of time stops flowing. Time still exists as a dimension, but it no longer progresses. Every moment becomes identical, an infinite repetition of stillness. The universe doesn't end in an explosion or collapse. It ends in a kind of eternal now, a frozen calm so complete, that even the idea of before and after ceases to make sense. The Big Rip, a hypothetical finale. Some theories propose an even more dramatic fate, the Big Rip. If dark energy's influence continues to strengthen, its expansion could grow violent, not gentle and exponential, but catastrophic. In this scenario, space would not only push galaxies apart, it would begin to tear apart the galaxies themselves, then solar systems, then planets, then atoms, then the very fabric of space-time. In the final fraction of a second, everything, even the concept of space, would disintegrate. Reality would end not in silence, but blinding instant of separation, as every distance becomes infinite. And yet, even that would not be destruction, but transformation, a resetting of the cosmic field, perhaps giving rise to something new. The quiet eternity. Whether the universe ends in a big rip or fades eternally into cold emptiness, the final state is the same. A cosmos that has no structure, no direction, no temperature, no time. It is the simplest possible thing, pure geometry, pure potential. And in this ultimate stillness, there is beauty. The story of the universe, from the first burst of creation to the last whisper of expansion, has been one long breath, in and out, order and release, birth and rest. Now, the breath is complete. When existence becomes memory. If we could somehow perceive this future from outside of time, we might see the universe not as a sequence, but as a single, shimmering structure. A vast tapestry of every event that ever was, coexisting in timeless balance. Every photon that ever shone, every life that ever lived, every motion of every atom, all still there, woven into the geometry of what once was reality. Nothing is truly lost, it is simply still. The death of space and time is not an ending, but a stillness so perfect that nothing more can happen, and nothing more is needed. Section 5. The Quantum Afterlife. When nothing gives birth to something. In the silence that follows the death of space and time, the universe appears complete. There are no stars, no light, no gravity to pull, no energy to move. It is an infinite stillness, cold, flat, featureless, and yet even this perfect quiet may not be the true end. For deep beneath the apparent calm, beneath the fabric of space itself, a quiet restlessness remains, a flicker of uncertainty, a whisper of possibility. The universe, it seems, can never be completely still. The restless vacuum. Physicists once imagined that empty space meant nothing, a total absence of matter, energy, and fields. But quantum mechanics revealed something very different. Even in its lowest energy state, the vacuum is alive with activity. Particles and antiparticles flicker in and out of existence, borrowing energy from the void for an instant before vanishing again. This restless foam of creation and annihilation is called quantum fluctuation, and it means that nothingness is never truly empty. It is the quietest hum imaginable, the subtlest vibration of reality itself. Even in the last frozen moment of the cosmos, this quantum field endures. It is the canvas that remains after the painting has faded away. Zero is not nothing. In everyday thought, we imagine that zero means absence, a complete lack. But in the language of physics, zero is more like balance. The vacuum of space, even when devoid of matter, still possesses 0-point energy, the lowest possible energy that a system can have. It cannot be removed or reduced. That energy, though faint, means that space retains a pulse, a deep, eternal hum, so soft and low that it underlies all of existence. And that hum, as delicate as it is, has power. In fact, it may be the very thing that birthed our universe in the first place. The universe from nothing. One of the most remarkable insights of modern cosmology is that the Big Bang may not have been a creation from something, but a quantum fluctuation, a random event within a larger field of nothingness. In quantum terms, nothing is unstable. If it exists at all, it can suddenly, through statistical chance, tunnel into a state of higher energy, producing a burst of space, time, and matter. This process, known as vacuum fluctuation cosmogenesis, suggests that universes can arise spontaneously from the quantum foam itself. Our own cosmos, with its galaxies, stars, and living beings, may have been one such fluctuation, a spark in the dark, a ripple that grew. And just as it once began, it may happen again. The infinite sea of possibility. Imagine a vast, timeless ocean, not made of water, but of probability. Every possible state of existence ripples beneath its surface. In this ocean, universes are like bubbles. They form, expand, and eventually fade, but the sea itself never empties. The laws of physics we know might simply be the rules that govern our particular bubble, one among an infinite foam of possible worlds. When our universe fades completely, its quantum field does not vanish. It simply returns to this cosmic ocean, where it may one day give rise to another bubble, another universe, born from the same eternal vacuum. This idea is sometimes called the multiverse, but that word can sound too busy, too crowded. In truth, the vision is quieter, a vast, calm sea of infinite beginnings, vacuum decay, a fragile existence. There is, however, a more fragile side to this quantum sea. Physicists have proposed that our current universe might not occupy the true lowest energy state. Instead, it could be a false vacuum, a metastable form of space, like a ball resting in a shallow valley, with a deeper valley beyond it. If a quantum fluctuation were ever to push the universe into that lower state, it could trigger a vacuum decay, a catastrophic event in which the laws of physics themselves would change. In that instant, particles would transform, forces would shift, and the very structure of space would collapse into a new configuration. It would not be an explosion, but a silent rewrite, a new physics overwriting the old. And yet, because the universe is so vast and time so patient,
This transformation, if it ever occurs, may lie beyond all measure of waiting. It is, perhaps, the quietest possible rebirth. Nothingness as creation. To human minds, the idea that nothing can create something feels paradoxical. But in quantum reality, it is as natural as breathing. The universe does not need a cause in the way we understand causes. At its deepest level, it exists because existence itself is the most stable state. Absolute nothingness, a perfect zero, is unstable. Something always stirs, always fluctuates. This is the secret heartbeat of eternity. Even when all things end, the potential for new beginnings remains. Nothing, it seems, is not the opposite of something. It is the womb of it, the endless cycle. Perhaps this is the true rhythm of the cosmos, not a single birth and death, but a sequence of awakenings, each universe blooming from the stillness of another's end. Our universe may not be the first, nor will it be the last. Across infinite time, the quantum field may breathe universes the way a forest breathes air, in and out, forever. Each cosmos, unique in its laws, its physics, its possibilities, flickers briefly before dissolving back into the quiet field that birthed it. The poetry of persistence. So perhaps the end of our universe is not an ending at all. It is the natural turning of a page in a book without beginning or end. When everything becomes nothing, the nothing itself becomes fertile, ready to bloom again. And though no consciousness may exist to witness that new creation, the act of creation itself is enough. For even the silence of the void is part of the same eternal story, the story of something arising from stillness, and stillness returning to something. The quantum afterlife of the universe is not the heaven or a rebirth as we imagine it. It is the persistence of possibility, the quiet truth that even nothingness cannot stay still forever.
Section 6. The Eternal Return, Cycles of Cosmic Rebirth. When you gaze at the night sky, you are looking into a pattern, a rhythm so vast and subtle that even time itself seems to breathe to its beat. The stars rise and fade. Galaxies spin and dissolve. Worlds form, live, and vanish. It is a quiet, endless pulse, a cosmic heart beating across eternity. Perhaps the universe itself shares this rhythm. Perhaps creation is not a single story, but a cycle, a recurring dream that wakes itself again and again. The dream of the eternal return. The idea that the universe repeats itself is ancient, older than physics, older than science itself. In Hindu cosmology, the universe is said to move through cycles called kalpas, each lasting billions of years, each ending in destruction, only to be born anew from the ashes of its predecessor. The Greeks, too, spoke of the ekpyrosis, a fiery collapse and rebirth of the cosmos. The Stoic philosophers imagined a universe that burns itself to ash and then rises again, exactly as before, like a phoenix that remembers its flame. And today, modern cosmology finds itself whispering similar ideas, not from myth, but from the mathematics of space and time. The big bounce, when time breathes in and out. For decades, we believed that the universe began with the Big Bang, a single, unique explosion from nothingness into everything. But what if that was only half the story? The Big Bounce theory suggests that the Big Bang may not have been the beginning, but the aftermath of a previous universe's collapse. Before our universe expanded, another universe may have contracted, its stars, galaxies, and matter drawn together by gravity, until space itself folded in upon itself. In that final moment, when density reached its peak and space compressed beyond limit, something remarkable happened. It bounced. Instead of collapsing into eternal silence, the universe rebounded, its energy exploding outward in what we call the Big Bang. From death came creation, a cosmic inhale followed by an exhale, gravity's reversal. This idea, while poetic, has scientific grounding in quantum gravity. In the extremely dense, hot conditions near the Big Bang, quantum effects begin to overpower gravity. According to models like loop quantum cosmology, space itself has a discrete structure, a network of tiny loops. When the universe contracts, these loops resist being squeezed too tightly. At a critical density, they push back, reversing the collapse into expansion. It's as if space remembers that it cannot vanish. Even in its smallest, hottest moment, the universe carries the seed of its own renewal. The cosmic phoenix. If this bounce happens not once, but endlessly, then the cosmos is like a phoenix, perpetually burning itself away, only to rise from its own embers. Each cycle of expansion and contraction would erase much of what came before, yet the underlying energy, the structure of the physical laws, would endure. Perhaps our current universe is not the first to shimmer with galaxies. Perhaps there have been countless before, each slightly different, each carrying faint echoes of the last. Maybe deep within the cosmic background radiation, the universe's own fossilized light, there are subtle patterns, circular imprints, tiny ripples, that hint at universes long gone. Some cosmologists, like Roger Penrose, believe that we may already see traces of these past worlds in the faint afterglow of the Big Bang. He calls this idea conformal cyclic cosmology, a theory that sees the end of one universe as indistinguishable from the beginning of the next. In this picture, the cosmos doesn't just die, it transforms, again and again, forever. The universe without a memory. What would it mean, philosophically, if the universe repeats itself endlessly? It means that, on the grandest scale, time is not a straight line, but a circle. And if the circle is perfect, if each cycle truly mirrors the one before, then everything that has ever happened will happen again. You sitting here, reading these words, you may have done so before, and you may do so again. But perhaps not exactly. Maybe in the next cycle, the laws of physics will shift by an infinitesimal degree. Perhaps a single particle will decay a fraction of a second earlier. A universe is born, almost identical, but not quite. And from that imperceptible difference, an entirely new cosmos unfolds. A new sequence of galaxies, a new kind of light, a new kind of life. Each cycle, the universe dreams itself a little differently. Entropy and renewal. There is, however, a cosmic law that resists repetition. Entropy, the measure of disorder. In our universe, entropy always increases. Stars burn out, energy spreads, order dissolves into chaos. So how can the universe renew itself if it grows more disordered with every passing moment? The answer may lie in the deep transformations that occur during collapse. As the universe contracts, the extreme gravity near the bounce may erase old information, compressing matter into pure energy, resetting the cosmic clock. In this way, entropy may not be destroyed, but rather recycled, converted into the raw material for the next beginning. Just as a forest fire clears the way for new growth, the collapse of a universe may prepare the ground for a new one to bloom. Time's infinite breath. If these cycles are real, then time itself is not endless, but eternal. The difference is subtle yet profound. Endless time moves forward without stop, a line stretching infinitely, but eternal time is cyclical. Self-renewing, a wheel turning without destination. Each turn of that wheel contains all of creation. Birth, growth, decay, and rebirth. A cosmic breath that neither begins nor ends. The death of one universe is not a tragedy. It is the necessary silence before the next symphony begins. The calm between universes. Between one cycle and the next, there may exist a moment, not a moment as we know it, but a timeless pause, a space of pure potential. It is in that silence that the next universe gathers itself, like a wave curling before it breaks. This perhaps is the truest kind of peace, a stillness so complete that even time itself rests, preparing for the next heartbeat of creation. So if you ever wonder whether the universe will truly end, remember, the cosmos may not know how to stop breathing. Its stillness is only temporary. Its death is only a prelude. For even in the deepest dark, the rhythm of being continues. The eternal return, the infinite inhale and exhale of existence itself. Section 7. The slow fade of light. The era of black dwarfs. There will come a time so far into the future that the human mind can barely reach it, when the stars themselves begin to fade. The night sky, once brilliant with fire, will grow dim. Galaxies will thin out like mist, and the last remaining stars will burn their final fuel and slowly die. This is the era of black dwarfs, a time when the universe, once filled with radiance and motion, descends into a calm, cold stillness. It is the age when light itself surrenders to the dark. The long twilight begins. Right now in our cosmic present, the universe is still very young, only about 13.8 billion years old. Stars are being born every second in clouds of glowing hydrogen, but even stars have lifespans. The largest live fast and die young, burning through their fuel in just a few million years. Smaller ones, red dwarfs, burn slowly, gently, lasting trillions of years. When these ancient embers finally fade, the universe will enter a new and quieter era. The cosmic night will deepen. The grand pageant of starlight will come to an end. The birth of the black dwarfs. When a small star reaches the end of its life, it does not explode in a supernova. Instead, it quietly sheds its outer layers, leaving behind a glowing ember, a white dwarf. A white dwarf is no larger than Earth, yet it holds the mass of a star. Its light is not from fusion, but from the leftover heat of its past. It glows faintly, like a dying coal in the ashes of a fire. Over billions upon billions of years, it will slowly cool and fade. Its light will shift from white to red, from red to black, until it no longer shines at all. At that point, it becomes a black dwarf, a dead star, cold, dense, and utterly dark. No one has ever seen one, because the universe is still far too young for any white dwarf to have cooled that much. The first black dwarfs will not exist for another quintillion years. That is, 1,000,000,000,000,000 years from now. Time itself will seem to have thickened, stretching into an endless silence. A universe without daylight. When the last star flickers out, there will be no dawn anywhere. Planets will drift through eternal night, their frozen oceans silent beneath the black. Galaxies will become ghostly structures, held together only by gravity, their stars extinguished. In this era, the universe will be a vast collection of black dwarfs, neutron stars, and black holes, a cemetery of suns. Yet it will not be entirely lifeless. Even in this deep darkness, processes continue, slow, delicate, almost imperceptible. Atoms may still decay. Matter may still transform. The universe may still whisper its faint final notes. The faintest flickers of heat, though black dwarfs no longer shine, they are not entirely dead. They still contain matter, and matter, even at near absolute zero, contains energy. Each black dwarf, as it cools, will radiate an unimaginably small trickle of heat. Photons of infrared light, so faint they would take eons to cross a single meter of cosmic emptiness. It is the last warmth of creation, spreading gently through a universe that has forgotten what light looks like. This is not a violent end, but a peaceful one. The fires of the cosmos do not go out in chaos, but in serenity, a slow fading, a return to stillness, time beyond time. To speak of these future ages requires a new kind of language. Human lifetimes measure time in decades, planets in billions of years. But the black dwarf era unfolds on scales that dwarf imagination. 10 to the 37 years, 10 to the 40th years, 10 to the 100 years. In that unimaginable expanse, entire galaxies may drift apart. Collisions between remnants may still occur. And gravity may continue to sculpt silent interactions between the dead husks of stars. Some rare collisions between black dwarfs might ignite briefly, creating a faint flash of light, the last sparkle in an otherwise eternal night. Each one a final memory of the cosmos that once was. The black hole companion. Even as black dwarfs cool into obscurity,
black holes will still haunt the universe. They will drift through the cosmic dark, devouring what little matter remains. Some of these black holes may capture black dwarfs, swallowing them silently, adding to their own mass. Over incomprehensible spans of time, even black holes will begin to evaporate, emitting Hawking radiation, a slow leakage of energy that will eventually destroy them. As they vanish, they will release their final photons into the freezing dark, a last exhalation from the lungs of the universe. And then, at last, the universe will be left with almost nothing at all. Stillness at the end. Imagine this distant cosmos, a sea of darkness, littered with the cold remains of 1 billion trillion suns. No warmth, no motion, only faint traces of radiation, so sparse that the cosmos itself is barely distinguishable from zero. Yet this stillness is not tragedy, it is peace. All that ever burned, all that ever shone, has completed its journey. The universe has exhaled its final breath. The fires of creation have cooled into the gentle quiet of eternity. And in that silence, if anything still exists, it is balance, the perfect calm of energy spread evenly, like an endless sigh. The poetry of fading light. When the last light fades, it will not go out all at once. It will dim gradually, like twilight lingering long after sunset. Somewhere, in that endless future, the last photon may travel alone through infinite space, carrying with it the faint echo of all that ever was. It will not know where it came from, nor where it is going. It will simply move forward, a single thread of light, weaving the final line in the story of everything. The era of black dwarfs is not a moment of sorrow, but of completion. A time when the cosmos, having burned for eons, finally rests. And yet, as we saw before, from rest may come renewal. For in the ashes of stars, in the cold of the vacuum, the seeds of new universes may still quietly stir.
Section 8. The Kingdom of Black Holes. The universe devours itself. There will come a time when the stars are gone, when the great galaxies have dimmed into darkness, and when all that remains are the shadows of gravity, black holes drifting through the cosmic night. This will be the black hole era, a time when these silent titans become the rulers of existence. No light will shine, no warmth will glow. Only the invisible pull of gravity will mark the shape of what remains. The universe will be quiet, yet far from empty. It will be full of secrets, hidden within horizons that no light can cross. The reign of the invisible, black holes are the last stage in the evolution of massive stars. When a giant star collapses under its own gravity, it compresses all its mass into a point so dense that even light cannot escape. This creates a singularity, a place where space and time fold in on themselves. Around this point lies the event horizon, the ultimate boundary of reality. Anything that crosses it, matter, energy, even light, can never return. In the distant future, as stars fade and galaxies dissolve, these event horizons will be the last true structures left in the cosmos. Each one will be a dark monument to the universe that once was.
The Great Consumption. During the black hole era, the cosmic stage will be silent.
But the actors,
These ancient black holes, will continue their work. They will drift through the darkness, merging and devouring what remains of the universe. Black dwarfs, neutron stars, and any remaining fragments of matter will fall slowly, inevitably, into their waiting gravity wells. Each collision will send out faint ripples through the fabric of space-time, gravitational waves, the last echoes of motion in a dying universe. These waves will pass silently through the empty void, stretching space ever so slightly as they go. It will be the final whisper of the cosmos, a soft vibration in the eternal dark. Galactic graves. Even now, our Milky Way has a heart of darkness, a supermassive black hole called Sagittarius A star. In the far future, long after the stars are gone, this black hole will remain. It will have devoured much of what once orbited it, drawing in gas, dust, planets,
and even the remnants of long-dead stars.
Other galaxies will meet the same fate. Their central black holes will grow, swallowing the remains of their homes until only a few titanic black holes drift through the emptiness. Eventually, through cosmic collisions, these giants may merge, forming even greater entities, each heavier than billions of suns. The universe will become a kingdom of darkness, ruled by these silent emperors.
The silence of the event horizon.
To an outside observer, a black hole seems still. Nothing moves, nothing escapes. But inside, if such a place can even be described, the laws of physics as we know them cease to function. Space and time switch their roles. Falling inward becomes inevitable, like time itself pulling all things toward the singularity. Yet, there is beauty in this, too. Black holes are not merely voids. They are cosmic archives, record keepers of everything they consume. Though their information seems lost, physicists believe it is somehow preserved, encoded in subtle patterns on the surface of the event horizon itself. Stephen Hawking proposed this in his famous black hole information paradox, that every bit of matter, every photon that ever fell in, still leaves an imprint, a trace written into the fabric of the whole. So even when the universe forgets its stars, the black holes will remember.
The slow death of giants.
But even black holes cannot live forever. For all their power, they slowly lose energy through a process called Hawking radiation. It is one of the most delicate dances between gravity and quantum physics. A faint quantum shimmer along the event horizon that allows black holes to emit radiation and gradually shrink. Large black holes will take unimaginable spans of time to evaporate. Timescales so vast that they defy human language.
A black hole the mass of our sun
Would take 10 to the 67th years to fade away. Supermassive black holes would last up to 10 to the 100th years. In that unimaginable future, when they finally vanish, they will release their final photons, a faint, fading sigh as the last pieces of the universe return to the vacuum. The last flicker of existence. When the final black hole evaporates, the universe will be empty. No stars, no matter, no radiation stronger than the faint hum of a few dying photons. It will be the ultimate quiet, a universe that has reached perfect equilibrium. And yet, even then, something remains. The structure, the possibility, the fabric of quantum fields that still ripple invisibly beneath the void. The last flickers of Hawking radiation may still dance across the emptiness, brief glimmers marking the end of the longest story ever told. It is as if the universe, after a lifetime of creation and destruction, is finally allowed to rest. Gravity's final gift, the rain of black holes, though dark and cold, is not without purpose. In their gravity, the universe learns how to end gently, not through explosion, but through surrender. They gather what remains, fold it in upon itself, and give it back, piece by piece, to the quiet quantum field from which everything first emerged. In this way, black holes are both destroyers and healers, the universe consuming itself so that it can one day become whole again. The peace after power. It is tempting to see this era as bleak, but there is a deep serenity in it. For billions upon billions of years, the cosmos has burned with chaos, birth, destruction, and light. Now, finally, it comes to stillness. The black holes reign in silence, not as tyrants, but as caretakers of what remains. They hold the last embers of creation, guarding them until even they fade away. When the final one dissolves into radiation, the story of the visible universe will end, but perhaps not the story of existence itself, because, as we have seen, from the quiet comes creation, and the vacuum, no matter how empty, never stays empty for long.
Section 9. The era of pure darkness, when space itself grows cold. The universe, once vibrant with light, motion, and sound, gradually fades into quiet. Stars have died. Black holes have evaporated. Galaxies are no longer luminous islands of matter, but whispers in an endless void. Now begins the era of pure darkness, a time when the cosmos is stripped of all luminous sources and energy spreads thin across an infinite expanse. Space itself grows cold, not in a sudden collapse, but through patient, eternal dilution. Even light, the swiftest traveler, becomes irrelevant, its energy stretched and scattered across the expanding void. The great cooling. In this era, the temperature of the universe approaches absolute zero. The cosmic microwave background, the lingering warmth from the Big Bang, has been redshifted so dramatically that it now contains almost no energy at all. Particles, once dancing with energy, drift slowly in the emptiness. Electrons and protons float through the vacuum like cosmic flotsam, moving too little, too slowly to interact meaningfully. Even the faintest of atomic reactions has long since ceased. The universe is effectively frozen, a landscape of potential stretched to its extreme limit. Matter in isolation. During this time, matter itself exists in rare, isolated clusters. Any remaining particles are separated by vast distances,
so immense that they may never meet again.
Collisions are improbable. Gravity no longer binds effectively. The universe is simply too spread out. Atoms exist, but they are inert, as if the cosmos has exhaled and left them suspended in absolute calm. From a human perspective, it is impossible to measure motion here, because there is virtually none. Time still flows, but in this frozen expanse, it has lost all of its drama. The fading of space itself, expansion continues, space stretches, carrying even the isolated particles further apart. Distances become so large that the very notion of near loses meaning. Galactic clusters, once held together by gravity, drift beyond event horizons. Matter is no longer connected in any significant way. It is a universe without interaction, a universe without events. This is the ultimate entropy, not just the decay of matter, but the decay of connectivity itself. The cosmos becomes a place where no change occurs, and where nothing can influence anything else. The last photons, all photons, even the faint remnants from black hole evaporation, have redshifted beyond detectability. They wander through space as virtual echoes, never interacting, never observed. Light itself has been reduced to mathematical possibilities. There is no illumination, no radiation, no energy capable of performing work. The universe is not cold in the human sense alone. It is cold in the deepest, fundamental sense, a stillness where energy no longer exists in usable form. It is a complete, perfect silence, the philosophy of nothing. In this era, one might ponder what it means for a universe to exist. From the outside, it appears utterly lifeless. Yet the vacuum persists, a subtle sea of potential that quantum mechanics assures us can never truly be empty. This reminds us that existence does not require drama, or fire, or motion. Even in the absence of all measurable activity, the universe is still a structure, still a phenomenon, still a place of possibility. In that sense, darkness is not death, but a calm, resting state of unimaginable scale and serenity, cosmic loneliness and eternity. The era of pure darkness is a realm of ultimate solitude. There are no observers, no stars to shine upon, no particles likely to interact, no signals to traverse the vast emptiness. It is a time where the universe exists only in the faintest sense, as structure without action, as presence without change. It is an eternity in which time itself loses its meaning. Yet in this quiet, there is a profound beauty. The cosmos has reached equilibrium, a perfect balance where motion, light, and energy have dissolved into the stillness of space. This is the universe at rest, its story complete in a way that is neither tragic nor celebratory, but serene. The possibility beyond. Even here in the deepest cold, there is still a whisper of potential. Quantum fluctuations persist, even when all observable matter has faded. Tiny ephemeral particles appear and vanish, like sparks from a fire that has long since burned out. The vacuum may still birth new universes, new expansions, new possibilities. So even in this ultimate darkness, the cosmos is never truly finished. It is a place of calm, yet also a womb of possibility, waiting silently for the next chapter to begin.
the calm before rebirth. The era of pure darkness teaches a lesson about the nature of existence. It is not a universe defined by light or motion or interaction. It is defined by stillness, a stillness that contains the seeds of everything, if only one knows where to look. Even as stars vanish, even as black holes evaporate, even as time stretches to its extreme, the universe holds on to potential. The silence is not empty. It is complete, calm, and eternal.
Section 10. The heat death and the final equilibrium. The universe is patient. It moves on scales of time and space so vast that human imagination struggles to grasp them. From the first burst of the Big Bang to the death of the last star, it has been a story of motion, transformation, and energy. And yet, all motion must eventually cease. All gradients must eventually flatten. The universe will reach a state of absolute equilibrium known as heat death. A calm so profound that it seems to exist outside time itself. The slow dissolution of energy. In every process, energy moves from a higher state to a lower one. Stars burn hydrogen into helium, releasing heat and light. Galaxies collide. Gravitational potential transforms into motion, and black holes slowly evaporate. But each transfer increases entropy, the measure of disorder, over trillions of years. This process will continue until no energy differences remain. No gradients exist to do work. No forces drive change. The universe becomes a vast, static expanse, filled with cold, diluted radiation and inert particles scattered across infinite space. The end of change. In this final state, nothing new can happen. Atoms exist, but they do not interact. Photons may drift eternally, but they cannot collide in any meaningful way. Even quantum fluctuations, the fleeting sparks of possibility, become exceedingly rare. The universe is not empty, but it is frozen. It is a cosmic pause, a state of ultimate rest. Time continues, but it has no effect. Nothing changes, and nothing can ever change again. A universe of uniformity. Heat death implies uniformity at its most extreme. Every corner of the cosmos reaches the same temperature, the same density, the same quietude. There are no hot stars, no swirling galaxies, no planets, no life. The universe has become a perfect, homogeneous field. There is no light, no motion, no difference, only equilibrium. It is the universe as a blank canvas, the ultimate serenity. The poetry of stillness. To imagine the heat death is to imagine a stillness so complete that even time loses its meaning. Yet there is beauty here. The cosmos has fulfilled its destiny. From the first burst of energy to the final evaporation of black holes, every process has run its course. The universe has burned through its potential, and what remains is the quiet, perfect balance of all that was. In this sense, heat death is not tragic. It is the final sigh of creation, the ultimate peace, the quantum horizon. Even in this state, the universe is not entirely inert. Quantum mechanics suggests that the vacuum itself still vibrates with possibility. Particles may flicker briefly into existence, then vanish. Tiny fluctuations may still occur, but they are isolated, rare, and fleeting. The universe is silent, but it is not empty. Potential lingers in the quantum fabric, as subtle as a heartbeat beneath the stillness of eternity. Eternal calm. Heat death marks the final equilibrium of the cosmos. There is no heat to drive engines, no energy to fuel stars, no forces to shape matter. It is a calm so complete that the universe seems to breathe in unison. Its last motion, the gentle, imperceptible rhythm that can be felt only in imagination. All that remains is balance. All that remains is quiet. All that remains is existence in its simplest form. Reflections on the end. To contemplate the heat death is to confront the ultimate serenity. It is a universe without drama, without fear, without violence. It is a universe that has completed its story and now rests in peace. And yet, even in this eternal calm, there is the possibility of rebirth. From the quiet of the vacuum, new universes may arise. From the final stillness, creation may begin again. In this way, the heat death is not the end of everything, but a transition, the calm after the storm, the stillness before the next great awakening. Section 11. The fate of matter. Protons, neutrons, and the longest lifetimes. Even after the last stars have faded, after black holes have evaporated, and the universe has reached its cold, silent equilibrium, the matter itself, the atoms that make up everything, continues its quiet existence. Though the cosmos appears empty, protons, neutrons, and electrons linger. They are survivors of creation, enduring long past the lifespan of stars, long past the light of galaxies, long past the universe as we know it. The longevity of protons. Protons are remarkable. These positively charged particles reside in the nuclei of atoms and form the foundation of matter. According to current theories, protons may be immortal, or they may decay over inconceivably long timescales. The most optimistic predictions suggest that proton decay could occur over 10,034 to 10,036 years, trillions upon trillions of times longer than the current age of the universe. Until that decay happens, protons remain steadfast, even in the cold, dark, empty universe, like cosmic embers holding on to the memory of creation. Neutrons and their fragility. Neutrons, the neutral companions of protons, are more delicate. Within atomic nuclei, they are stable, bound together by the strong nuclear force. But outside nuclei, free neutrons decay with a half-life of about 15 minutes. In the far future, most neutrons will already have disappeared, leaving protons and electrons to persist as the last remnants of ordinary matter. Even as these particles drift alone, they form the quiet skeleton of the cosmos, reminding us of all that once existed. Atoms in isolation. Electrons orbit protons to form atoms, and atoms once clustered into stars, planets, and galaxies. In the era of pure darkness, atoms will be dispersed across vast distances, isolated from one another. Interactions become incredibly rare. Collisions between atoms
may take 10 to the 40th years or longer. It is a universe in which chemistry ceases, where bonds cannot form, where molecules cannot interact. Yet the fundamental matter persists, quietly enduring, like seeds waiting in a barren field. Exotic matter and the end of nuclear stability. On unimaginably long timescales, even atomic nuclei may undergo transformation. Some theories predict that protons could decay, transforming hydrogen atoms into lighter particles, eventually leaving only radiation and electrons. Heavier nuclei, like carbon, oxygen, and iron, are expected to break down over time, slowly disassembling into their constituent particles. Matter itself dissolves into simplicity, returning to a form closer to the void from which it once emerged. Dark matter and the unknown. While ordinary matter fades, there is another player in the cosmic drama: dark matter. Dark matter is mysterious, comprising roughly 85% of the universe's matter. It does not interact with light, but its gravity shapes galaxies and clusters. In the far future, dark matter will continue to drift silently. It may be stable forever, or it may decay over timescales beyond imagination. Regardless, it quietly endures, a ghostly backbone of the cosmos, persisting even when ordinary matter has mostly vanished. The final particles. Eventually, the universe may consist only of long-lived fundamental particles, protons, electrons, neutrinos, and possibly dark matter particles. All organized structures, stars, galaxies, black holes, will have dissolved. The cosmos becomes a sea of isolated particles, drifting through an ever-expanding void. It is a universe stripped of complexity, yet still full of potential, a quiet testament to the endurance of matter itself. The end of the ordinary universe. In this final stage, ordinary chemistry and biology are impossible. No life can survive. No stars can shine. No planets can form. Yet the particles themselves remain as echoes of a once vibrant universe. They are the ultimate survivors, the longest-lasting legacies of creation. Even when everything else fades, they quietly testify that something once existed: matter and time. To imagine this future is to think on scales that boggle the mind. The universe will continue expanding, particles drifting farther apart, interactions becoming rarer with each passing eon. Time stretches infinitely, yet these particles endure. They exist beyond the era of light, beyond the reign of black holes, beyond the slow cooling of space. In their persistence lies a kind of calm, a reminder that even when structures collapse, even when galaxies vanish, even when stars die, the essence of the universe, its matter, continues, quietly, peacefully. A universe of particles. Ultimately, the far future universe may be a sparsely populated space of protons, electrons, and dark matter. No light, no warmth, no energy gradients, just matter and the endless expanse. Yet this simplicity is a form of beauty. The universe has passed through every stage, from the Big Bang to star formation, to life, to the death of light, to black hole dominance, to the dispersal of matter. And even now, in the quiet of near total stillness, the universe has not vanished. It persists in its simplest form. It's a gentle, eternal calm, the last sigh of creation before the final silence of pure potential.
Section 12. Proton decay and the ultimate dissolution of matter. Matter, the substance of everything we know, has been patient. It has endured through the fires of stars, through the rain of black holes, through the slow cooling and spreading of space. Yet even matter is not eternal. On inconceivably long timescales, even the smallest building blocks may succumb to the gentle inevitability of cosmic decay. This is the stage of proton decay, the quiet unmaking of matter itself and the ultimate dissolution of the universe's ordinary substance. The fragility of the proton. Protons are the foundation of atoms, the positively charged heart of hydrogen, carbon, oxygen, the building blocks of stars, planets, and life. For billions of years, protons appear eternal. They endure through stellar fusion, through gravitational collapse, through the dispersal of galaxies. But according to some theories of particle physics, protons may decay. This is not sudden. It is unimaginably slow, so slow that the universe can age trillions of times over before a single proton might vanish. Predictions suggest proton decay could take 10 to the 34th to 10 to the 36th years, a span that dwarfs every cosmic epoch that has come before. Yet eventually, if proton decay is real, even the fundamental building blocks of matter will disappear, the end of ordinary matter. As protons decay, hydrogen atoms vanish. Larger nuclei, carbon, oxygen, iron, gradually disintegrate into their constituent particles. Electrons, once bound to nuclei, drift free across the cooling void. Neutrons, already unstable outside nuclei, are long gone. In this quiet unraveling, all familiar forms of matter dissolve into a sea of lighter particles, positrons, neutrinos, and radiation. The universe loses its familiar structure. No planets, no stars, no atoms. Nothing remains recognizable from the cosmos we inhabit today. A universe of radiation and particles. After proton decay, matter as we know it ceases to exist. All that remains are free electrons, positrons, neutrinos, and photons of radiation, the fundamental remnants of a universe that once teemed with life and light. Even black holes have long evaporated through Hawking radiation, returning their energy to this sparse cosmic sea. The universe has become a near-perfect void, filled with only isolated particles and faint, dispersed energy. It is a universe almost entirely quiet, almost entirely still, entropy at its limit. Proton decay represents the final stage in the universal increase of entropy. From the Big Bang to the death of stars, from black holes to the dispersal of matter, entropy has steadily grown. Now, as protons dissolve, energy differences vanish entirely. No work can be done. No motion occurs that can affect another particle. This is the ultimate thermodynamic equilibrium. The universe has reached maximum entropy. It has completed its journey from order to disorder, from vibrant energy to perfect stillness, the silent aftermath. In this era, the universe is almost unimaginably empty. Distances between particles are immense, so interactions are extraordinarily rare. Even gravity has little to act upon. As the universe continues its eternal expansion, the last photons drift across vast voids.
their energy diluted beyond recognition. Neutrinos wander alone, almost unaffected by anything else. It is a universe stripped to its barest essence, existence without form, without interaction, without heat. Yet there is serenity here. The cosmos has run its course. It has played out every story from the first flicker of the Big Bang to the last particle. The final dissolution is not violent. It is gentle, gradual, a quiet fading into calm eternity. The end of everything we know. With proton decay, ordinary matter, the familiar substance of the cosmos, vanishes entirely. No planets, no stars, no galaxies, no life, no light. Only the most fundamental particles remain, isolated, drifting endlessly. It is a universe we can scarcely imagine, so different from our vibrant, warm cosmos today, so simple, so empty, yet containing the echoes of all that ever was. Even in this stark finality, there is elegance. The universe has transformed completely, yet it remains a coherent structure governed by the laws of physics, a prelude to the infinite. Even after proton decay, the story of the universe is not necessarily finished. Quantum fluctuations still occur, even in near total emptiness. In the long stretches of the void, new possibilities arise, tiny sparks of energy that may, in some distant realm, give birth to new structures, perhaps even new universes. Though all familiar matter is gone, the potential for creation persists. The universe, in its quiet and stillness, remains fertile in ways we cannot fully comprehend. The ultimate calm, the universe's final era, is a time of ultimate peace. No collisions, no explosions, no starbursts, no motion, no heat, no life. Only quiet, expansive emptiness. Yet in this quiet, we can feel a strange sense of beauty. The cosmos, after unimaginable time, has arrived at a state of absolute equilibrium. Its story has been told, its matter has dissolved, its energy has spread thin. The universe rests, silent, simple, complete.
Section 13. Quantum fluctuations and the possibility of new universes. Even in the profound stillness following proton decay, the universe is not entirely empty. Beneath the apparent silence, beneath the cold, dilute scattering of the last particles, the vacuum itself hums with subtle potential. This is the realm of quantum fluctuations, tiny, unpredictable variations in energy that occur even in perfect emptiness. In the far future, these fluctuations may play a critical role. Even when ordinary matter is gone, the vacuum is never truly devoid of possibility. It is a canvas waiting for a spark, a calm sea that can, under the right conditions, give rise to motion, to energy, to creation itself. The quantum foam. On the smallest scales, space is not a smooth void. It is a frothy, turbulent sea of quantum uncertainty. Particles pop in and out of existence. Fields oscillate. Even in the apparent absence of everything, there is activity at the subatomic level. This quantum foam represents the potential for new beginnings. A vacuum fluctuation in the right region could, theoretically, lead to the birth of a tiny self-contained universe, a bubble universe, expanding from nothing into something entirely new. The seeds of creation, Physicists call this concept vacuum metastability. The vacuum we observe today is stable enough to support our universe, but quantum fluctuations suggest that pockets of space could spontaneously transition into a lower energy state. If this happens, the new region could inflate, creating a brand new cosmos with its own laws, its own time, its own space. Even after the heat death, after all matter has dissolved, the universe may harbor the seeds of creation. In this way, the end is not absolute. From the quiet of the ultimate equilibrium, possibility may still arise. Eternal potential. This future is almost unimaginable. The universe, so patient and so vast, could continue its story endlessly. Even after entropy has flattened everything, even after the last particle has faded, quantum fluctuations ensure that the cosmos is never completely inert. In a sense, nothing is ever truly final. Creation and destruction are ongoing processes, not confined to the dramatic fireworks of stars and galaxies, but hidden in the quiet rhythm of the quantum vacuum. A universe that breathes. Imagine a cosmos so silent, so cold, so empty that human minds cannot even perceive its scale. Now imagine that this emptiness is alive in its own subtle way, that within the stillness, tiny fluctuations ripple, tiny sparks emerge, tiny beginnings wait patiently for the chance to grow. This is the paradoxical beauty of the universe. Even in its most complete stillness, it holds the possibility of movement, of birth, of renewal. It is a universe at rest, yet never lifeless. A universe quiet, yet filled with latent potential. The endless cycle from the Big Bang to the heat death, from the last black hole to proton decay, the universe has followed a grand narrative. And yet, perhaps it is not a linear story at all. Perhaps it is cyclical, or branching, or eternal in ways we cannot fully comprehend. Each quantum fluctuation, each tiny ripple in the vacuum, could be the seed of a new chapter, a new Big Bang, a new cosmos, a new story of light, motion, and matter. Even in silence, the universe whispers the possibility of everything, the ultimate calm with possibility. As we consider the far future, we see a universe that is both quiet and fertile, a cosmos stripped of stars, black holes, and ordinary matter, yet rich in potential. The ultimate stillness does not imply nothingness. Instead, it is a calm foundation, a blank canvas, upon which the next creation may someday arise. Even in the deepest dark, even after the heat death, even after the final particle dissolves, the universe holds within it the quiet promise of a new beginning. It is a vision of infinite calm, infinite possibility, and the ultimate serenity of existence itself, the eternal symphony of the cosmos. As we return from this meditation on the end of all things, we are reminded that the universe is both finite and infinite. It begins in fire, grows in light, evolves through complexity, and eventually fades into a gentle calm. Yet even as entropy flattens everything, even as stars, black holes, and protons disappear, the universe never truly ceases to be. From the subtle dance of quantum fluctuations, new possibilities can emerge, new universes can bloom,
and the grand story continues in ways we may never witness. The cosmos is patient, eternal, and in its final calm, it teaches us a quiet truth. Even endings can harbor beginnings, and even silence can contain infinite potential.